Coming up next on the IP Talk stage, John Maneatis from True Circuits, presenting analog timing IP for your digital chips.
Low configuration that you would use typically in DDR applications, as well as a multi-slave DLL that can be used for other clock recovery type applications. And these designs are all available, as I said, in all the major foundries from 180 nanometer to 28 nanometer. And the designs are configured to be extremely general in nature, so they can easily support a variety of standards, as well as work with ARM processors and whatever really you're trying to do. The designs are very flexible in ways that make it very convenient to use. For example, they have very large multiplication ranges. They can multiply from like 1 to 4,000 with a wide output frequency range. And that kind of flexibility makes it very easy to use them in a variety of applications on the same chip. So typically, our customers may license a single design and then use a number of instances for different functions on chip, like generating a core clock, a memory clock, a video clock, or clocks for other interfaces that they may have. And the designs are very low jitter, very process tolerant, and are available in a variety of form factors. The designs are fully pin programmable, and also we will perform customization as needed to make them work as well as possible in our customer applications. And the designs are very well documented and also supported throughout the production ramp process. We perform integration reviews and other design reviews with our customers to make sure that they're using the designs properly and haven't made any simple mistakes that could compromise their performance. So we've been at this for some time, over 14 years, and since then we've gone from quarter micron all the way down to now 20 nanometer development. So at this point, our 28 nanometer IP is fully verified in all of the different flavors of TSMC and Global Foundry, and they are being shipped right now to customers. So let me speak a bit about our business model. So we try to keep it simple and straightforward as possible. The license terms are all based on a per use or multi-use arrangement. So there's basically fees paid for a design, not per die royalties or anything like that. And we have a number of ways in which we distribute our IP. We have partnerships with a lot of semiconductor companies that provide direct or indirect sales channels for our IP. We work with a number of IDMs, ASIC foundries, and web portal IP libraries like ChipEstimate. And we also work with design service firms like eSilicon, GUC, and others through our True Partner program. We also work with other IP providers and a number of sales reps and distributors around the world. So, one of the key things, let me just go on here. So, you may ask, why choose TCI? Well, we're the experts at this. We didn't just, start our operation, last week or last year. We've been at this for a long time. We've gone through a very large number of chip implementations, probably more than 1,000, and have got a very good, an excellent track record for first-time silicon success. You know, we design test chips to fully validate our IP, but I mean, we design it to work on first silicon, whether it's a test chip, a production chip, whatever it is. And we do this through our fully automated design process that involves automation at every level, from design characterization, silicon characterization, layout, everything. Even model generations or front-end models and stuff are very consistent. We have close marketing relationships with all the leading foundries, IDMs, and design service firms. We've got a staff of designers who will offer pre-sales support as well as post-sales support through integration reviews and help during production ramp. And an impressive list of high production volume customers spanning the semiconductor industry. So, you know, if you're looking for timing IP, True Circuits is the place. So you can investigate more of what we have to offer through ChipEstimate.com and use our IP in your next chip. So I'm here if you guys have any questions. Someone has to have a question. All right, I'm going to have to start picking on people here.
All right, I have one.
Go ahead, Sean.
What is the importance of low jitter for PO?
Well, jitter is a key parameter for PLLs. So jitter impacts could impact in many different ways depending on how the PLL is used and what it's used for. PLLs used in to generate maybe a core clock for a processor would be impacted in terms of setup time. So the more jitter there is, the more setup time margin you need, and therefore the lower speed your design will be able to run at. But jitter can also impact timing interfaces through both setup and hold time, depending on the nature of the interface, and you know, reduce the eye opening, things like that. So jitter is definitely a key parameter and one that you should definitely look at.
What kind of applications is your IP currently present?
Pretty much everything. So the IP is very general in nature, so they can be used in many different applications. So you'll find them in consumer devices, game boxes, cameras, enterprise routers, automotive systems like ABS, pretty much everywhere. Good question. So probably every couple of months, you know, we'll bring the site up to date. You know, in terms of IP maintenance, you know, we're always improving our designs and, you know, improving our modeling and documentation and stuff. But a lot of that doesn't impact the listing on ChipEstimate. So ChipEstimate is more just kind of, you know, high-level specs and things. So how do we verify our IP? Yeah, so the IP is verified in, can I ask myself a question and get one of those? No. So the IP is verified both pre-silicon and post-silicon. So pre-silicon verification we do with our automated characterization environment. And we run thousands of simulations on the designs. We have a very large computer farm that we run. We actually use our own version of SPICE, so we're not limited in any way. So we will run thousands of closed-loop simulations, millions of open-loop simulations, you know, to verify that the circuits will work well under all conditions. And then for silicon verification, you know, we make test chips, and we will then take that IP and verify it over, you know, all the PVT conditions, and we'll do it over a large number of samples. And because it's automated, you know, we can get very repeatable results. We can, you know, make sure that we've done the characterization correctly, and if we're not happy with something, we can go back and recharacterize everything, and you know, until we've done it right. Oh, sure. Yeah. So the question was, do we list what special features we need for the different process variants? And yeah, metal stacks and things. Sure. So the IP is designed not to use any special features. So basically, we will work with whatever combinations you're using in the process. So metal stack, we know the designs use the lower levels of metals, so typically in TSMC processes are not impacted by higher level metal stacks. But for VTs and things, we typically just use standard VTs. And but if you are using some special combination, we might be able to take advantage of it, and we could discuss that with you. Sorry. Yeah, so the designs have you know, some amount of digital logic, and then, you know, a lot of analog circuitry. So the analog, most of the circuitry is characterized directly in SPICE. Though for some of the more complex designs, we do functional verification through mixed mode simulations. So we don't need to do, they're not so complicated that we need to do things like static timing analysis. Instead, we can just, you know, cover everything with a large set of vectors and make sure that we haven't missed anything.